Today, I'm going to introduce you the solution of ESP Rainmaker plus Meshlight, creating a stable, fast, and maintenance-free network for your devices. Before going into the details, I'm going to share with you some background and context of why we introduce you such a solution. And you may have experienced and tried out different kinds of the mesh for your use cases, driven by BLE, Zigbee, Thread, and the Wi-Fi mesh, and even like the LoRa or the MB IoT. So these all solutions have its pros and cons depends on your use cases. And one shall evaluate your solution based on the at least below four dimensions: cost, range, power, and maintenance. And we have identified several major pain points in the market by using improperly of the mesh solution and mismatch for their use cases. It's pretty hard for maintenance sometimes for the customer to to maintain the mesh network because it's too complex and hard to trace and identify the bugs. And also, on the other hand, it takes maybe extra cost to develop the products in terms of the software development, as well as the options of the chipset could be rather high. And thirdly, insufficient stability. So it means like if you want to reach the longer distance, sometimes you need to sacrifice like the power, and also the stability could be another problematic issue, that losing the signals or the message doesn't deliver to the specific nodes. And the fourth point is about penetration. And especially when it comes to the larger industrial sites, or like even like the household, inside of the house and outside of the house, and how does the signal get penetrated to another site is become a problematic issue when the customer design their mesh solution. So based on which we are trying to introduce you the combination of the Meshlight plus our IoT cloud solution, ESP Rainmaker, and offering you in a more stable manner, easy maintenance, and also in a secure and highly scalable way to develop your own IoT solution in the mesh scenario. The Mesh Lite is a lightweight mesh network solution based on the 802.11 and TCP protocol, featuring the network self-healing, stable connection, broad signal coverage, and easy maintenance. And on the other side, ESP Rainmaker is a lightweight IoT cloud solution that fully embraces the AWS serverless architecture and can be deployed under your own AWS account. So with this open SDK, you can develop your own IoT solution with a minimum amount of the code efforts and with maximum security and availability. So let's look into a bit about the solution architecture. On the left side, you got all the devices within the mesh network that it can formulate the mesh automatically. And on the other hand, all those mesh devices are connected to the external network. It's assigned with the IP by its parent node and also by the router. And it's discoverable and traceable via the external network. So on the other hand, when you look into the architecture of the ESP Rainmaker Cloud, you can see the complete infrastructure on the cloud. The complete infrastructure on the cloud is maintained by the ESP Rainmaker. So as long as you define a clear data model for your own device type, it doesn't matter if it's a lighting device or if it's like the charger station or the solar panel. It's on your decision to decide what kind of the devices that you're going to design in such a mesh solution. And on the other hand, we are integrating the third-party cloud system like the Alexa and also the Google Voice Assistant and the HomeKit. And we also deploy the dashboard under your AWS account as well, so you can manage all those connected devices via the dashboard and see the status, the connected status, and even like the health monitoring of those devices. And you can develop some like the mobile apps based on the REST API, and you can design freely about how the user interactions and the workflows on the application level. So let's look into in a more detailed way of the mesh light structure. The ESP mesh light is a set of the solution based on the soft AP and the station mode built upon the 802.11 protocol. So it means like it can formulate multiple downstream connections to based on the soft AP interfaces, while it also supports one upstream connections via the station mode. So it inherently results in the tree topology of the complete network in the mesh solution. So it means like all those nodes in the mesh light is assigned with the IP addresses by its parent node in order to communicate directly with the external network. So let's look into further those concepts in the mesh lights. We got the root node acting as a bridge between the nodes of the mesh light network and the external IP network. And all the communication like can be going down and up via the root node. And secondly, you got the leaf node. This is like, well, it does not generate further downstream connections, ensuring the network layers will not exceed the limit. So it's on the bottom of the complete mesh network. And we also have the intermediate parent node. We call it child node because it's on the bottom, it's on the middle level of the complete mesh network, as it stands for both the soft AP mode and the station mode. And we also have the concept of the idle node, which is pending, not yet joining the mesh network, and is considered as the idle node. So we also have embedded the root node selection mechanism in the automatic manner as well as the manual mode. So what does it mean? In case in the complete mesh network, the root node gets, say, disconnected. So the complete mesh network maybe go crash. And being the case, we enable the self-healing feature that allows the root node get selected, reselected, but it depends on the signal strength relative to the router. And on the other side, sometimes in some use cases, the customer needs to appoint one single root node because the root node could be the screen controller and managing the numerous lighting devices. And so all the devices will get provisioned via that root node. So this is also feasible in our mesh light network solution. So we have understand the basic concept of the mesh light, and let's turn around a bit on the ESP Rainmaker, our IoT cloud solution. So as I mentioned, the ESP Rainmaker is a IoT cloud solution that fully built upon the AWS serverless architecture and also embrace the AWS managed services like the User Cognito, Lambda, SES, SQS, SNS, and also S3 DynamoDB API gateway. So what does it mean? It means like you own the high availability and security thanks to these managed services. So the AWS is like the lens and the resource provider, and where expressive on behalf, we build, being just like a contractor, build such a houses for our customer under their AWS account. We ensure providing you a great living experience based on all the AWS resources. So starting from a contractor and later we become a property manager role because we want to ensure the privacy and independency of the customer's living. But we will ensure you got a good living experience with the sufficient supply on like the electricity and the water supply. So this is the metaphor illustration about how you can leverage the ESP Rainmaker on your business. And to look into further, that we provide a richer feature list on the use cases in the more the end user side as well as the admin side, the OEM features. So we provide the user management, user device association, scheduling, device sharing, and the remote and the local control, etc. These features are aiming for like the end users use cases and the scenarios, but actually you can develop a lot of a great more end user feature based on the REST API released by the ESP Rainmaker. And on the other side, that you can also enjoy monitoring the numerous of the devices getting connected to the Rainmaker cloud through the dashboard. And you can understand the complete configurations of the backend. So you can even deploy a production field and also the test field. So you can switch easily between the two different modes and building the firmware and the app easily and doesn't impact the production environment. And on the other hand, that you can do some OTA job and maintain your OTA image to the Wi-Fi MCU or to your host MCU. That's all feasible through our dashboard, and you can you can design your indicators that help monitor the device health and also some insights into user behaviors or the device behaviors. So that's pretty flexible and offers you great power to design your IoT solutions. So in general, the value propositions that we draw from the combination of these two different solutions is first, easy maintenance. So it takes only small efforts for the implementation. And the after sales would be super easy for the complete infrastructure, almost none, because you don't need to invest for a team to maintain the cloud, to maintain your firmware, because all the SDK has been maintained and developed by Espressif. So second of all, the low cost. So you can develop the mesh light solution on our cost-efficient chipset options and support, and the development is rather easy and it takes less efforts for the complete solution design. And we provide you with the complete example guiding you how a mesh devices getting connected to a Rainmaker cloud, the provisioning, and also the controlling, the commands, and also how you design and define a device type, the payloads, and also the service and the function parameters. And thirdly, pay as you grow. So what does it mean? So it means like, since ESP Rainmaker is based on AWS serverless architecture, so you don't need to pre-provision any compute resources on AWS cloud, and you don't need to maintain these kind of resources as infrastructure. So even if your business are small, you don't need to worry about paying in advance for these idle resources. So this provides you great flexibility in the beginning and low investments in the initial stage. And the fourth point, which is very important, the independence. So which means that all the data belongings are owned by the customer, not by Espressif. That will ensure that you gain the complete independency for your niche business segments, and including the device and the user data. So let's look into a bit into details how actually the root node commissioning works. Initiated from the app side by establishment of the BLE connections. The app will send the Wi-Fi SSID and password, user ID, secret key, mesh ID, random number. And only in the meantime, the root node would generate the soft AP SSID and the password as well. So sending back the root node ID and notifying the soft AP SSID and password will be done in the same time via the BLE connection. And afterwards, the root node device will start going to the cloud, initiate the provisioning process by sending the user ID, secret key, and also the node ID. And at the same time, the pairing of the BLE will be removed from the app side, also from the device side. And the app, once receiving from the node ID information, that will goes to the cloud together with the secret key to acquire the request ID from the cloud in order to check the user node mapping completion status. So after the provisioning is completed, the root node will report node level information like the mesh ID, random number, soft AP SSID and password, self IP, and self MAC. And after the root node get provisioned, you might wonder how the child node commissioning is done. It's pretty much sharing a similar process with just a few exceptions. Let's look into, well, when the BLE connection is done between the child node device and the app will also send the Wi-Fi SSID and password, the mesh ID, random number, user ID, secret key. And the only difference is this soft AP SSID and the password is sent by the app to the child node. So once the child node receives the soft AP SSID and it knows which root node in the mesh network it will go into join. So the child node device, after reporting back the child node ID, it will start joining the mesh network or created by that root nodes and assigned with the IP. And it starts with the provisioning and the user node mapping via Remeker Cloud. And on the other side, the app would do the same to acquire the request ID to also to check the completion status of the user node mapping. So when the provisioning is done, the node level information will be reported by the child node devices to the root node and the cloud respectively. So you may wonder how the mesh group is created, and actually there's the difference definition between the mesh group and the cloud group. So under like the single mesh network, those devices are actually maintained locally. So those devices can be allocated in inside of the house and outside of the houses. And how do you manage and control a specific batch of the devices that are only located in outside of the house, like in the yard? And this is why you need the mesh group under the same mesh network. So it can contains multiple mesh groups in the single mesh networks. And we have integrate that features in the Remeker Cloud with our mesh light solution. Let's look into the workflow. And starting with getting all the node information from the cloud, and the app will start parsing the node information and try to display the group device list. And you will know like all those nodes which can be divided into different mesh groups, and you start call the API of the groups to create the mesh group with the metadata. So the mesh group ID is kind of the tag to help the root node and the child node understand which mesh group they are in. So this information will be syncing up via the cloud to the root node and the child node respectively. The same with the action commands. If I want to try to control only the devices under a single specific mesh groups, the app shall request to get the mesh group details with the metadata from the Remeker Cloud, and the group ID, the node ID, along with the group metadata will be acquired, and also the commands together will with the root node ID, mesh group ID will be sent to the root node devices. So the root node device, once receive this information, it will do the broadcasting to all the child node devices amongst the mesh network. The child node devices who are under that mesh group ID will execute the action commands, while the rest of the devices which are not in that specific mesh group, they receive, but they don't do any execution, but they will do the broadcasting. So that will further extend the range of the signals. So this is extremely beneficial for many applications and scenarios. For example, like the solar panel, the new energy industry segments, and all those panels are installed, for example, on the roof of the houses and shall be managed remotely and also locally. And via the mesh light plus Remeker solution, this can be done easily. And thinking about like a plant growing system, when you have a screen controller that needs to manage all those numerous lighting devices on the different rooms or the areas or the sites, you need to understand, for example, when and how those lighting devices behave in certain time, and you need to manage that information precisely to different type of the lighting devices. And this can also be achieved via the combination of the mesh light plus Rainmaker. And the thirdly is like the warehouse lighting. It's pretty much you can think about in such larger sites. Sometimes the distance amongst the lighting devices could be far away from each other. So this can also be done via the penetration ability and also the distance that the mesh light can achieve. And this would be really beneficial for the scenarios that I mentioned above. And you can also develop your own solution for some niche use cases as you wish. So before we close the session, we can also look into a short video demos to demonstrate the process as I mentioned above. So starting with the provisioning for the root node. So this is the app built upon the ESP Rainmaker Cloud, and it starts searching the root node via the BLE. When the BLE connection is connected, and all those information will be exchanged between the nodes and also the app. And once the provisioning is done, you will see the app will acquire this information via the Rainmaker Cloud, and you can see the nodes already getting presented in the main page of the app. And you can see there's a small icon on the right corner that is also the icon standing for the mesh. And you can do the same actually on the UI side to representing the mesh nodes. And now it's provisioning for the child nodes. And we are demonstrating you the child nodes provisioning under single root node. And pretty much similar process that you see here, that all those child nodes get provisioned completely within that root node mesh. So it's also traceable from the Rainmaker Cloud, and you can do the control for the single devices via the Rainmaker. But you can also try to manage the creation of the mesh groups to control those the mesh devices individually. So this is the demos that how you can create mesh groups for the devices that you selected. For example, if you try to select a few of them out of a mesh network and make it the name a light group, and such a mesh group will be created and visualized in the Nova Home app. And you can try to do some actions, some commands on and off here, and you will see the lighting devices will just doing the execution of the commands accordingly. And it doesn't matter if what kind of action commands has been sent via the cloud to the root node, and the root node will be just do the broadcasting to those child nodes, and they will just do the execution accordingly. And the rest of the devices within that mesh network, they receive it, but they don't do any execution, as I just mentioned. Yeah, so this is like the short demo of the video, and you can actually refer to more details of the projects that we open source it on our GitHub. And you can type the keywords ESP Rainmaker or the Meshlight for the projects respectively. And we have the examples for you, and it's ready. Thank you very much. See you next time.